Assalamu alaikum. Welcome back to Civil Engineering 24/7 YouTube channel. I am Civil Engineer Adnan Ahmed, and today I will teach you how to find the depth of foundation, which is very important to know. Each and every civil engineer must know that how to find the depth of foundation at site. As an engineer, we need to know the depth of foundation. So there are general parameters, formulas to follow towards this question. Okay, so I expect that you are familiar with Rankins formula, okay, which is in your BTech, geotechnical engineering. You remember one subject? The soil is there, how to find the depth of the soil. If there is a soil depth, how to find the depth of the soil. Okay, there is a pit. If it is earthwork excavated, then how much the depth according to loading conditions you find depending upon the various bearing capacities, right? So let us move towards the question: how to find depth of foundation. So Rankins formula is used to determine the depth of the foundation. Okay, minimum depth of foundation. Okay, minimum depth of foundation. Clear? Now let me write it down the formula. So capital D is equal to, okay, capital D is equal to P by W 1 minus sin theta divided by 1 plus sin theta whole square. This is the Rankins formula. D is equal to P by W 1 minus sin theta 1 plus sin theta of whole square. So this formula is generally used to determine the Rankins formula to depth of the foundation. Clear? Let's move towards the parameters of the formula which you need to know when you have the condition of formula to solve. Okay? So generally P is nothing but, here P by W is there, right? So P is your and W. Okay, P is your structure load, or you can say building load. Okay, building load in kg per meter square, right? What I am trying to say is there is a foundation. Okay, this is foundation. How to determine the depth of the foundation? That's my question. For that we use this formula, Rankins formula, to determine the depth of foundation. I hope you are getting what I am trying to convey here, right? So let us move towards formulas. P by W. P is your structure load, building load, kg per meter square. Many members don't know how to find the depth of the foundation, so you can find it through Rankins formula. Next, W is your density of soil. Okay, this is, I will consider it as suppose 1500. Okay, 1500, and this I will take it as example. I will take it as 2300. Okay, so structure load 1500, density of soil 2300. I am considering for example. Then if I take what is theta here, theta is angle of repose. Okay, angle of repose or internal friction of soil. Okay, internal friction of soil. Okay, so you know that what is P, what is W, and what is theta. P, W, theta. That's it, completed. Now I will take an example for solving a problem. Okay, see it very carefully. So example, I am taking it as example. Okay, the formula is 1500 P by W, right? P by W. So phi is 1500 divided by 2300 brackets 1 minus sin theta. Sin theta, I am taking it as this theta value. I will consider it as theta. I will take as 25 degrees. Okay. So 1 minus sin 25 divided by 1 plus sin 25 square. Like this, you solve with Rankine's formula to find the depth of the foundation. Okay, I hope the concept is very clear to you all, right? So this is very important lecture on depth of foundation. Please note it down while teaching. Generally for 6-story building, if suppose there is 6-story building, 6th-floor building, we consider the depth of foundation 1.5 to 2 meters according to the site conditions. But it's somewhat generalized idea which I have said you that 2 meters to 1.5 meters is considered for the depth of the foundation for 6-story building, right? And generally the foundation is not only considered with Rankine's formula. Before applying the formula, we need to know which kind of sand is used in the foundation, whether it is hard soil, loose soil. The geotechnical engineer will investigate on all those things. And the building load depends upon the bearing capacity of soil. Before doing any kind of design or any kind of construction, you need to know the bearing capacity. And one more thing, you need to know that the columns which we are constructed at site are according to the basic bearing capacity of soils. You may observe at site that the columns are at different positions. That is due to the different bearing capacity of soil. The loading bearing, how much load is occurring from the structure, that's load bearing capacity under the soil. If the soil is liquefied condition, then we cannot construct the house at that site. This was a generalized idea to know. For more interesting updates, please subscribe my channel Civil Engineering 24/7. Meet you next session, guys. Until then, Allah Hafiz.